Hello and welcome. Today we will see basic instruction in the TIA portal, that is comparator. But this instruction is most powerful and frequently used instruction in the PLC programming. Now let us start. So in the TIA portal, if we go to the instruction pan, so there is one section called comparator operation. So there we can see 5-6 types of comparator instruction. So basically comparator compares two values of same data type and it will give the result in a boolean variable. Okay, now let us see. So there is a equal to, not equal to, greater than equal to, less than equal to, greater than, less than, value in range, value out range, valid value and invalid value. So now let us use one by one instruction. So first one is a equal to. Now what we will do? We will add 1 dB. So here we will take 1 temperature process value and 1 set point. And we will take some outputs so that we can use rest of the instruction with these outputs. Okay, so here the data type of temperature, it is real, we will take it real, but we can use this instruction for integer, double integer, real, byte, word, double word, unsigned integer, uh, unsigned double integer, signed integer, string. So here we are using it for real. So simply we can add here temperature. So automatically it will take the data type real. So here if the value of temperature and if the value of set point are equal, then our output, it will become a true. Okay. So what we will do, again we will take here not equal to instruction. If temperature value and set point value are not same, then only our output will become a true. So here not equal to. So here in the first network, if temperature and set point are same, then output becomes true. Here if temperature and set point, if they are not same, then only output will become a true. Now we will download it into the PLC and we will check it. So here we are using simulation. So see, if temperature and set point values are same, here at the moment the values are 0 0, so output becomes true. If we change the temperature, output is off. But at the same time, if temperature and set point in the not equal to instruction, if they are different, output becomes a true. If we make it same, if we change the set point to the 27, output becomes off. Okay, so this equal to and not equal to instruction, it will act opposite. Okay, so if we make other than 27, output becomes true. Okay, so in this way we can use equal to and not equal to instruction. The next one is greater than and less than. So we will take two instructions simultaneously. Greater than equal to, less than equal to. So if temperature is greater than or equal to set point, then our output becomes a true. And here if temperature is less than or equal to set point, then our output becomes true. Now let us download it. So here at the moment temperature is 28 degree and set point is 27 degree. So output is true. If we change it to 27, now at this moment temperature is not greater than set point, but it is equal to set point. So this instruction talks about greater than and equal to. So if temperature is greater than, so earlier it was greater than 27, so output was true. But here temperature is equal to set point, that's why output is true. So this instruction talks about greater than and equal to. So if we change this temperature set point 26.999, our output should become off. See, our output is off. So if we change it to 20, output should be off. But if we make it again to the 27, output should become a true. If we make it 29 or 100, as it is greater than 27, output is true. In the same way, if temperature is less than and equal to 27, then only output 4 will become a true for less than equal to instruction. So here we will make it 50, output is off. If we make it 27, then output should be true because this is less than and equal to. Here equal to is satisfying, that's why output is true. If we make it less than 27, output should be true. PLC went in a stop mode. Okay, that is fine. Okay, now temperature is 27. Here we make the set point 26. So now condition is not true. If we make the set point 27, output is true. And if we make the temperature below than 27, output should be true. But if we make it higher than 27, 27.0001, output should be off. See, so in this way less than equal to and greater than equal to instruction can be used. Now the next one is greater than and less than. Greater than and less than instruction. So here, so this greater than and greater than equal to instruction are same, only here equal to consideration is not in the greater than and equal to instruction. So output, next output we will consider output 5, and here also we will consider next output 6. So here temperature should be greater than set point. Here equal to, consider, we are not considering here equal to, so that's why we are using greater than and less than instruction. So here temperature is greater than set point, that's why output is true. Now here if we make the equal to the set point, that is 27, then output should be off. See, output is off. But if you see the greater than equal to instruction, here output is on, because here equal to consideration is there in this instruction. Here equal to consideration is not there, only greater than instruction. So for the only greater than instruction, we are using only this greater than instruction. So like this, see, the set point and temperature are same, but output is off. But in the less than equal to instruction, output is on. So here if we make the temperature less than 27, output should be on. See, temperature is 26.999, output is on. So next one is in range value and out range value. If the value is within the range, then output will be true, and if the value is out of range, then value will be true. So here we will add two more tag, minimum range, maximum range. Data type, here we are taking real, so we can use it for integer, double integer also. So here minimum range, so here value we will take temperature, and here maximum we will take maximum range. So we will take next output, we will download it into the PLC. So here now we will change the range first. Minimum range we will take 10 degree, and maximum range we will take 30 degree. So if the temperature, that is this value, is not within this minimum and maximum, then output will not become a true. But if this temperature is between this minimum range and maximum range, then this output will become a true. So now temperature is 0, minimum range is 10, and maximum is 30. If the value of this temperature, if it is from 10 to 30, then output will become a true. So here we will change the temperature. Now if we make it 10, it should be true. So it will be true for 12, it will be true for 25, it will be true for 30, but if we go beyond 30, it will not be true. See, now the temperature is 30.0001, output is off. But if we make this temperature again in the range, output will become a true. So in this way, in value, in the range instruction we can use. In the same way, if the temperature is out of this minimum and maximum range, output will become a true. So here at the moment temperature is within the range, that's why the instruction, this output of this instruction is off. If we make it 9.99, output should become a true. See, output is true, and at the same time output of this in range instruction, it is a false. So now again we make it 35, output should be true. Again we make it 20, output should be off. Again we make it below 10, that is 6, output is on. So in this way we can use in range and out range instruction. The next one is okay and not okay instruction. So here we will take 9, and the last one here we will take 10. Now, and here we will take temperature. Now why this instruction we can use, we will see. So this OK instruction, if the data type of this tag, that is temperature, if it is valid, so at the moment we have taken it real. So if the data type is real, so value in this tag is real, then only output 9, that is output of this instruction, is true. So if the data value of this temperature is valid, then only output will become a true. And at the same time, if the data type of this temperature is invalid, then output will become a true. So now valid and invalid, we will check it. So now value of the temperature is valid, that's why output is true. So here not okay. So the temperature with the value of temperature is okay, that's why output of this okay instruction is true, and at the same time output of this instruction is false for the not okay. If we put wrong value in the temperature tag, output of this okay instruction, it should become a false, and at the same time if the wrong value is there in the temperature tag, output of this not okay instruction, it should become a true. So at the moment what we will do, we will insert some garbage value, that is hexadecimal value we will insert in the temperature. See, so the output of this instruction, okay instruction, it becomes a false, but not okay instruction, that means we are entering wrong data type, wrong value in the real value, that's why the output of not okay instruction, it becomes a true. So in this way we can use all these equal to, not equal to, greater than, equal to, less than, equal to, greater than, less than, in range, out range, okay and not okay instruction in the PLC programming. So I hope you like the video. If you like the video, please like, share and subscribe this video. Thank you.